Hello everyone, we're going to finish out the unit with the rational problem solving. Now the best way that we're going to learn how to do these is really just get into it and see as many problems as we can. You're going to pick up the patterns and get really good at these. Now as usual with problem solving, the hardest part is going to be deciphering exactly what they're telling us and what they're asking us. But like I said, with practice you're going to be a pro. We have a few simple steps to follow here, including defining a variable, writing an equation, and solving the problem. Now, I also want to draw attention that it says remember to write answers in complete sentences, or at the very least provide the units, because with rational problem solving, this is real world applications and just our numbers won't mean anything and won't receive full credit. We have to note what those numbers mean. Now the other thing I want to say before we get started is that we are still working with rational functions as we have for the entire unit. So that means we are going to be seeing things set up as a ratio. Remember at the very beginning our definition of a rational function was a fraction with two polynomials, one on top and one on the bottom, where the bottom polynomial did not equal to 0 so that it wouldn't be undefined. Okay, so keep this in the back of your mind as we're going through and setting up these problems. Number 1, Shelley can paint a fence in 8 hours, Karen can do it in 4 hours. How long will it take them to do the job if they work together? Okay, so kind of a hidden step here is to get ourselves organized and figure out what we know and what we don't know. Once we come across what we don't know, that's where we're going to be defining a variable to describe what's going on there. Okay, so let's go through. Shelley can paint a fence in 8 hours. So I'm going to make myself a note that Shelley, represented by S here, can paint one fence in 8 hours. On the other hand, Karen, she can do it in 4 hours, in half the time. How long will it take them to do the job if they work together? So together, and they're still doing the same job, so they're still doing one fence. But do we know how long it will take them? No, that's what we don't know. And so that's where we're going to define our variable. Let's define T to mean the hours to paint the fence together. Okay, now let's set up and write an equation. Well, let's start with what we know. One fence in 8 hours, that can be written as a ratio like that. One fence over 8 hours represents Shelley. And they're going to be working together, so we're going to be adding the two ratios. And Karen's ratio is one fence in 4 hours. We want to find out, and this is going to be together, so it now equals how long they take to paint one fence together. And so this is the time that we're going to be solving for. From here, it's just solving rational equations like we did before. So we're looking for the least common denominator. Now we have some numbers. So the very first thing we want to find out is what the least common multiple between them is. And here it is 8. So that my least common denominator, when I take a look at all denominators, here I just have numbers, but there's a t, will be 8t. Now to clear my fraction, I'm going to multiply every term by 8t, or in other words, both sides of the equation by 8t. That's where the balance is coming from. 8t over 8 plus 8t over 4 equals 8t over t when I multiply through. 8's cancel out here, leaving just t. 8 divided by 4 is 2 plus that t, or write down that t there, not plus. And then finally over here my t's cancel, so it equals 8. Now remember, we're just solving the problem, so we're trying to isolate t. I'm going to put these together as 3t equals 8. Last step to isolate gives us that t equals 8 over 3. But we have to write our answers in complete sentences, and we need to make sure that what this number is actually answering our question. The question was, how long will it take them to do the job if they work together? That's exactly what t represents. Perfect. Now we just need to give meaning to this. Now 8 over 3, if you would prefer to get a better feel for what it actually means, is 2 2/3 hours. and there's that hours giving me the units. Now, in the interest of saving you from looking at my horrible handwriting on this, I will just leave it there with my number and the units and just say verbally how I would write this as a sentence. I could say it will take Shelley and Karen 2 2/3 hours to paint the fence together. Now, the last kind of hidden step is to make sure that it makes sense. That's the cool thing about problem solving. You can apply some logic to double check. They were painting the fence individually at 8 and 4 hours. When they worked together, we can only assume that they would be faster, especially if one person started one end of the fence and the other person started the other. And yep, that's exactly what we see. This time is less than they could each do it individually. Perfect. Let's see another one. All right, problem 2. Tim can stuff envelopes 3 times as fast as his daughter Georgia. They have to stuff 5,000 envelopes for a fundraiser. So there's the job that they're doing, just like before we were working with painting a fence. Working together, Tim and Georgia, there's together, looks like we're going to be adding ratios, can complete the job in about 4 hours. I've already kind of underlined this one because that's going to be the units in this problem, really important. How many hours would it take each of them working alone? All right, so let's go and see if we can figure out what's going on. So let's write what we know about Tim. Well, we know, like before we were painting one fence, that we're going to have to stuff 5,000 envelopes for a fundraiser. So we're going to see how each of them working alone compares to working together. So if Tim had to stuff 5,000 envelopes by himself, how long would he take? Well, we don't know. They didn't tell us. They just told us that Tim is 3 times as fast as his daughter Georgia. Okay, so let's define a variable. This time let's use x to mean the time in our units, hours, for Tim to stuff 5,000. Okay, so with 5,000 envelopes, Tim will be able to do it in X hours. How about Georgia? Well, she'll have to do the same task, 5,000 envelopes, but with the time, he says Tim can stuff envelopes 3 times as fast as his daughter Georgia. Now that could also be said that Georgia will take 3 times as long. And so Georgia we're going to represent with 3x hours. Now before we go on, let's make sure that this makes sense. Let's say that it takes Tim, 5 hours to stuff 5,000 envelopes. Now for him to be faster than Georgia, we'd expect Georgia's number to be bigger. And yep, we would do 3 times 5, she would take 15 hours. That makes sense. Okay, we're good to go on. Now the last thing we know is that when they're working together, they're able to do 5,000, let's stop writing that word, in about 4 hours. So let's set up our equation. Tim is going to have 5,000 over x plus Georgia 5,000 over 3x equals 5,000 over 4. All right. So before we even get started, I see that I have in common 5,000 everywhere. So to make my life easier, couldn't I just factor out that greatest common denominator? Indeed I can. So instead of having to work with this little guy, I'm just going to divide both sides by 5,000. That goes away. That's not a 6, that's a 5. Divide by 5,000. Goes away. That just leaves me 1 over x plus 1 over 3x equals 1 over 4. My least common denominator in this case is, well, the least common multiple of 3 and 4 is 12. And then my variable x. That gives me one of each thing that's in my denominators. Multiplying through by 12x plus 12x over 3x equals 12x over 4. Simplifying gives me 12 plus 12 divided by 3 is 4. My x's go away. Equals 12 divided by 4 gives me 3x. Moving up here, 12 plus 4, 16 equals 3x. Finally, x equals 16 over 3. Now before I can go ahead and circle my answer, I have to go back and see what was I being asked and how can I write this. How many hours would it take each of them working alone? Well, let's go back. What does x mean? Well, that was the time for Tim to stuff 5,000, so that's part of the answer. So I'm just going to write myself my little notes here. Tim is going to work in 16 1/3, which is also about 5 1/3 hours. And Georgia will take 3 times as long, which when I multiply that by 3, just leaves 16 hours. I could write this as a sentence as it will take Tim 5 1/3 hours and Georgia 16 hours to stuff 5,000 envelopes alone. All right, let's move on to the next one. See how these aren't so bad? Rosa can jog 5 miles downhill in the same time it takes her to jog 3 miles uphill. She jogs downhill 4 miles per hour faster than she jogs uphill. Find her jogging rate each way. Okay, now this is another big type of problem that we're going to encounter. So before we're working with adding rates together to find out how much time people could take doing a task together. Here we're going to have a little bit more information. We're just dealing with one person, but with different rates. Now, something that's going to be really important with these problems is to remember our distance formula, which I'm going to write right here. Distance is going to equal rate times time. Now, we have a lot going on here because Rosa's going both downhill and uphill at some point. And so let's organize our information with a chart. I'm going to write my information for uphill on one row and the information for downhill on this other one. The other information that I want is exactly what's related to this distance formula. So I'm going to use that capital D there to represent distance. I'm also going to want to have my rate and my time. That's how all of these things are related. Oof, I hope I left myself enough space. Okay, so now let's decipher. How far does Rosa run downhill? She runs 5 miles. So that goes, downhill. Fix it. Downhill, distance, 5 miles. How far does she run uphill? 3 miles. Now, do we know the rate at which she is jogging? Let's see, she jogs downhill 4 miles per hour faster than she jogs. So no, they just tell us a relationship, just like in problem number 2. But we need to figure out what that is. So we're going to represent what we don't know with an x. X is going to be the rate Rosa is jogging. Okay, so we do know that there is a relationship that she jogs downhill faster than she jogs uphill. So how much faster? 4 miles. So if we say downhill, we'll do a rate of x plus 4 if the uphill just represents x. So in specific, this is uphill. And then the rate plus 4 is her rate as she jogs downhill. How can I solve for d equals RT for t? Because it looks like that's what we're trying to find. Find her jogging rate each way. Next thing I want to ask myself is how can I solve this equation, d equals RT, for t? Because notice there's nothing in our problem anymore that really relates to time other than saying that she can jog downhill and uphill in the same time. So let's figure it out. Well, here it's just dividing both sides by r so that t equals d over r. Well, we have that information already, so t will be 3 over x for uphill, and for downhill it's going to be 5 miles over x plus 4. Again, what do we know about the time it takes Rosa to run uphill and the time it takes her to run downhill? It's the same. So we can set these times equal to each other. Since time is the same, we can set up this relation, and we have two options here. We can clear the fraction, as we did before with common denominator, or we can just cross multiply. So let's cross multiply here, which gives us 3 times x plus 4 equals 5x. This is the same thing that you would have arrived at if you had cleared the fraction. Distributing out, I have 3x plus 12 equals 5x. Moving my 3x to the other side, 12 equals 2x, x equals 6. Before I can finish out my question, I need to find her jogging rate each way. So I'm going to go here. Well, if the jogging rate is just x uphill, then Rosa jogs uphill at a rate of 6, and then what's my units? I'm using miles per hour, because that's how my rate was. And then downhill at rate of x plus 4, which is just 10 miles per hour. And I kind of already said that in the form of sentence, just really slow. All right, 4 and 5 I'm going to leave as an exercise for you. Let's skip ahead and take a look at number 6. A college basketball player has made 58 out of 82 attempted free throws this season. How many additional free throws must she make in a row to raise her free throw percentage to 90? Okay, so we're starting off with our ratio being that she made 58 out of 82 attempted free throws. What are we trying to find? We want the number of additional free throws she must make to increase her percentage to 90. Now, if we want to make more free throws, we're also going to have to attempt more to begin with, right? So let's see what these mean. This number indicates the ones that she makes, and this is our total. So in order to make more, we need to attempt more. In other words, whatever we add to the top, we have to count with the total number of throws that we're taking. Now, it's really important that it says that she must make in a row. So that accounts that whatever we do add, it's definitely, that's the only thing that we're adding to our total. She's not missing any from that point. Now, what do we want this to equal? 90%. And how do we write a percent as a fraction? Yep, we want that number, the percentage that we want, over 100. That represents 90%. Now the way we can solve this is just like the last one with cross multiplication. There's one thing that I want to do before though. I can simplify my life by going ahead and simplifying this fraction from the bat, right off the bat. Did you know that little trick about zeros? If they're on the edge, you can just cancel them out. And think about it, 90 divided by 100, I can divide both by 10, leaving me 9 over 10. Cross multiplying this now gives me 10 times 58 plus x, 82 plus x. Now instead of doing all this work, we're going to go through and just arrive at our answer, and x we'll find after all of the algebra is 158. Now it's really important that we write this in a way that it makes sense, and so the basket player basketball player will have to make 158 additional consecutive, because they're in a row, free throws. All right, and that's it for today. Tomorrow there will be some additional problems to practice on, but just make sure that you go back and really practice on 4 and 5 to make sure that you can do these on your own. Have a great night.